Good morning, guys. This is the continuation of Chapter 5, Equilibrium of Rigid Body. Now, in this video, we will discuss some particular cases, 2 and 3 force members, redundant problems, and improper constraints. So, this part, guys, the first one, which is 2 and 3 force members, can be used to facilitate your problem. So, if you notice the 2 and 3 force members, this will facilitate your problem and prevent you from spending a lot of time solving the equilibrium equations. And not only in this chapter, but in the following chapters. So guys, I want you to understand very carefully what is a 2 or a 3 force members. From its name, guys, 2 force member means that I have a member, any body, and this body basically is only subjected to 2 forces. Let's say this is F1 and this is F2. So why I should talk about 2 force members? Because in fact, a 2 force member has certain conditions to satisfy the equilibrium. Like this case, for example. Did you think, guys, that this case can achieve the equilibrium? Basically, never. Because in fact here, even if F1 is equal to minus F2, so even if F1 is equal to minus F2, which satisfy the first set of equations, sum of fx is equal to 0, sum of fy is equal to 0, because in fact F1 in vector form is equal to minus F2. Even if this condition is satisfied, however, guys, the sum of moments will never be satisfied. Because in fact, guys, these 2 forces will cause a couple moment that could not be equal to 0, and this couple moment will be equal to F times D since F1 is equal to F2. Which means, guys, in order to satisfy the equilibrium, these 2 forces should be on the same line of action so that the couple moment will never be happened. So if I have a body here, these 2 forces, F1, should be on the same line of action as F2. So let's say this is F2 and this is F1. I have another way to explain this fact, okay? So let's do it, guys. Assume that I have this body presented here in this slide. So I have a member, guys. So let's say this is the member. And I know, guys, that basically these 2 forces should be opposite in order to satisfy the equilibrium. Okay, so let's say this is F1 and this is F2. So they are opposite forces. How to prove that they must be at the same line of action, otherwise there will never be equilibrium of this body. Basically, let's say that this is A and this is B. And let's assume that they are not at the same line of action. So guys, if I assume that they are not at the same line of action and my answer will give me impossible, this means that they should be at the same line of action. So let's take the sum of moments around A. I know, guys, that F1 passes by A, which means, guys, that the moment of F1 is equal to what? Around A. The moment of F1 should be equal to 0 because F1 is passing through A, and that's why I take point A. And then I will have the moment of what? Of F2. So the sum of moments around A is basically equal to the moment of F2. Now I know, guys, in equilibrium that the sum of moments should be equal to 0, which means, guys, that M, the moment of F2, should also be equal to 0. So what does this mean? F2, the moment of F2 is equal to 0 means basically that F2 should also pass through A. So guys, I'm finding the sum of moments around A. I know that MF1 is equal to 0 because F1 is passing through A. So I still have MF2. MF2 around A is equal to 0 means that F2 should have passed by A. And that's why, guys, I will have here the same line of action. So F2 will pass through A, which means F1 and F2, they have the same line of action. Okay, now I can do the same around B. So sum of moment around B is also equal to 0. I know, guys, from equilibrium that the sum of moment around any arbitrary point should be equal to 0 to satisfy the equilibrium. So sum of moment around B is equal to 0 means also, guys, that the moment of F1 around B should also be equal to 0 because in fact the moment of F2 is already 0, F2 is passing through B. So what does this mean? This means, guys, that F1 should also pass by B, and this means that F1 and F2 have the same line of action. Now I can do the same using the third method. Let's do it. So this is another way to prove what we are saying for the two force members. So guys, let's take this example. This is a very general example where at A I have a force or a reaction, and this reaction is oblique, so it has two components, AX and AY. You can say that at A I have a pin, for example, because we'll be using this in chapter 6, I think. And at B, I have also two reactions, or I have an oblique force that has two components, BX and BY. So how to prove, guys, that for this two force member to be in equilibrium, I should have two opposite forces and I should have the same line of action. Let's do it. I will start by the sum of moments around B. So the sum of moments around B will give me what? I know that the sum of moment around B should be equal to 0 because this is the equilibrium equation. What are the forces passing through B in order to cancel out their moment? I have BX, BY, and AX. Don't forget, guys, that AX is through the x-axis, and I'm finding the sum of moment around B, which means, guys, since this is X and this is Y here, so they are a little bit rotated. Okay, so AX is also passing through B, okay, which means, guys, that I will only have the moment of AY. So the moment of AY, guys, believe me, these equations and this analysis is very important for you in the following chapters. Moment of AY is equal to 0 means that AY is equal to 0. So here I cannot say that AY, the moment of AY is equal to 0 means that AY is passing through B. No, AY could not be passing through B, it is passing through A, and in this case, AY is equal to 0. Now let's do the same for what? For the sum of moment around A. So the sum of moments around A is equal to 0. Means what? Now here I don't have AY is equal to 0, so the moment of AX is equal to 0, the moment of BX, because it is also passing through A, is equal to 0, so I only have the moment of BY. So the moment of BY is equal to 0, and since BY could not be passing by A, this means that BY is also equal to 0. So BY is equal to 0, so I can write this BY, this is equal to 0, means, guys, that for a two-force member, any general two-force member should only have two opposite forces having the same line of action to be in equilibrium. Guys, why is this important? Because in fact, as a matter of fact, if I have a member bend at both ends, I can directly deduce, guys, that the forces on this member at the ends of this member should be passing or should have the same line of action and should be opposite, and this will facilitate a lot of equations, a lot of solution in the following chapter. But remember, the only condition is that this force member here doesn't have any other external force, because if an external force, this could not be assumed as a two-force member. So guys, in conclusion, a two-force member is in equilibrium if what? If one, the forces are opposite, and two, the forces or the two forces, they have the same line of action. Okay, so let's now move to the three force members.